thing has seen a little bit better time in its life. The terminals there are just completely melted. I'm fairly certain the positive terminal is no longer attached to the board, so I'm not even going to bother opening it up. It also looks like it wasn't taken care of removing it. Maybe somebody was upset that the amplifier had a failure. So anyway, we're going to go ahead and remove the cover and see what all we can see. Give me 1 second here. I'm going to get a Ziploc bag for these screws. Cover is also held on by the side. Now it should be free. Is it? Is it not? We will see. So this is very good. Fortunately, it just looks like the part lifted from the board. Everything else is intact, but I'm going to have to go ahead and take all these transistors off. I'm sorry, take all the transistor clips off and take the board out. There's quite a few screws in here. Give me 1 second. I'm going to go get a couple more baggies. I don't think I have any. Alright, we'll take some more of this apart now. We'll get some bags. I'm going to put these little screws away. They were from a different project I was working on a little bit earlier. Now, the first thing I'm going to do is get all the exterior screws out and put them in one bag. And then all the interior screws I will put in a separate bag so I don't have to worry about the thermal paste. Now, this amplifier probably should have been designed different. Now, I'm not an amplifier designer, but it's 12,000 watts. Now, if we just do a little bit of basic math, 12,000 watts divided by our 12 volts is 1,000 amps. Now, if I'm not mistaken, you only can run 300 amps through 1 aught, or close to 300 amps to 1 aught. I'm going to have to break this to get this off. See if I got some heavy duty side cutters. Should somewhere. Not side cutters, but we'll see if we can break some of this plastic off. No. Okay, that's fine. We will work around what we have. I'm going to clean some of this stuff out the area for now. So let me analyze this and see how the best way to go about this is. Now, it's still connected at the top. Excuse me, I was checking to see if there are any screws in here. It is still connected at the top. order to disconnect it from here, I got a couple options. I could heat this up with hot air and the soldering iron, which I think that is my route I'm going to do here just to get this off. I'm going to set this up pretty high, around 350, and we're going to let that heat up there. I'm going to take the soldering iron with some flux to get a contact, and I'm going to also try to get some solder on here, but I don't know how well that will work. And I'm going to try to heat up the terminal here with a soldering iron as well, so I can melt it back down so I have a working point, because I don't want to just sit here and pry on the board. I'd really like to try to repair this as cleanly as possible. It is a pretty expensive amplifier. So now I'm just going to hold this onto the terminal until the whole terminal heats up, because that's what happened in the first place there. Yes, this is an old soldering iron. It seems to hold up. Owens, Chicago. I'll have to look at the soldering iron here later and see what it says. Well, let's see. It's okay. No SD card, not a problem. I'll have to put one in there so it doesn't want to show that. There we go. Now we're moving. Look at that. Coming down slowly. We'll take the hot air away. Oh, I'm going to pause the video for a minute as soon as I get this melted back down so I can fix this GoPro. Melted right back into place. I'm going to pull this extra plastic off because this is the only option I have there to get this off. Don't want to bend that, so I'm going to pause this video and fix this real quick. Give me just a second. Now we're back. Alright. So we went ahead and melted that down, so I'm going to heat this up and try to get this plastic a little more malleable. I'm also going to straighten out these legs while I'm in here. Alright. Try to work that out while it's hot. Can I get it? It's close. It's very close. We can get it. We can get it. Yes, okay. That metal's very hot now. We'll bend these tabs back since we're here. This is how the amplifier mounts. I feel like they should have made it a little more stout, but I did not design it, so I'm going to put this back in our plastic bag so nothing gets lost. And we'll check this out now. I would like to get this screw out. And now it will come out because I have that back. And out comes the plastics. Alright, that's all chewed up pretty bad. We have this back in here. However, I'm not confident that solder job is very good, so we're going to flip it over. We're going to do a little bit of reflowing. So I will be right back. I'm going to grab some Ziplocs. This way I don't get thermal paste on other stuff, and it's just the way I like to do it. if they're trying to cut cost or something, but the clamps that are held down look like the same thing they're using as bus bars. I could be wrong. Put all those together so I know that those stay together. And we'll open another bag. And we'll put in all of these 10,000 screws into the bag. Those in there. Take the magnet, collect the rest of these screws, and drop one down in there. Will that come out? Yes, it will. Okay. So, now that I put these in a separate bag because the thermal paste. Now that we have this done, we'll go ahead and clean up a little bit because nobody likes thermal paste. Okay. Now I'm not going to go yank this amplifier out. I'm going to gently lift it up and see if everything is freed. Yes, it is. So now, looks like a couple of transistor pads have stuck. I'm going to set this back down. And as we lift this, I'm just going to poke these pads and get them to stay down. That way I don't have extra heatsink compound. Now we'll do a two-hand slide off here. We're going to drop this down. Right out of here. Now I hold the circuit boards like this the best I can until I get two hands on them so they don't flex as much. Now these guys here are going to stay, so we'll put these back. All these have to come off and be cleaned anyway, so that's okay though. Go ahead and get some cleaning solution ready. Apply a liberal amount and clean all these transistors, because I don't put old thermal paste back on. We got to put new stuff so it's not dried out. Alright, give me just a second here. I'm going to find the brush if I can. May have fallen behind the desk. There we go. I am almost certain the only problem with this amplifier. I'm almost certain the only problem with this amplifier is that the terminal has melted off. That looks pretty good. I cleaned up nicely. Now we'll move to the next step, which is how to clean up this mess here. Well, to be honest with you, the mess is not as messy as what I thought. These I'll leave out for now. I do want to double check the thread was okay on this one. It seemed to be okay. Yeah, the thread is okay. I'm going to actually reuse these terminals, and what we're going to do on these terminals is use dual 1-aught input reducers. I'm going to beef this up here. This one has an extra trace coming out. I'm going to beef this up a little bit, and I'm going to add a little bit more solder, quite a bit more of a trace off of there as well. I'm going to try to add a jumper trace. So I'm going to heat this up real quick. It won't be real quick, will it? It's a heavy-duty component. That's actually pretty stout on the board. I do worry about it going somewhere when I am soldering, so I'm going to get my super grippers ready. I should hold it in place. Ample flux. It's a pretty big pad. Now this positive goes to all these traces. I think the connection was loose, and that's what caused it to heat up. Because this board looks okay. Maybe somebody was using aluminum wire. We don't use CCA. I don't know. Just speculating. Still flowing good. I'm going to move the iron over to get some more thermal mass. Or thermal conductivity, however I should word it. Okay, I want to get this over a little bit. I better do it while it's still hot, otherwise I won't have too good of a chance to heat it back up. It is equal to that post. It's okay. We'll flow some more solder on. If it wants to heat up, it'll heat up, and we'll reposition it again a little bit better. Okay, I'm happy with that there. Now on this board here, these are positives on the rail. So we need to get a big solder joint from here to there. So I'm going to scrape some of this solder mask back. To let the solder flow a little bit better. I'll take some sandpaper here. Still quite warm. I'm going to flow solder from this ball over because that is a connection point on the other side, a big bus bar. Get this out the way. That's why it's nice to have a big iron. You could not do this repair with a smaller iron. It would not be possible. I am not done yet. I would like to scratch these traces out here, or the solder mask off rather. And I'm going to flow this out if I can to the first one, the second ball here. I'm just removing the solder mask. I don't have a better tool to do so at the moment, so this is what we're using. Alright. Now since there's some peaks and ridges, we'll go back to sand that, and that should clean us up some. That should be more than sufficient to allow that current to flow. I'm going to remove these solder balls. This is too hot for me to want to clean with alcohol yet. I don't want to thermally shock any components of the board or anything crazy. So we'll let that cool down for a little bit. And then what we're going to be doing is putting it back into the case. And what I'll be using over these terminals here is heat shrink. I'll be sliding heat shrink over and cutting out the holes. This is the repair. There's no way I'm going to get this from Sound Digital. Like I shouldn't even waste my time messaging them. So we'll unplug the soldering iron. That was a good repair. New towel here, and we'll clean this up some more where we worked at. I really want to clean all this solder, the resin up the best I can. So I'll sit here for just a second and work at that. All right. It's still a little warm, but yeah, that looks like a pretty good repair. So crack there. No, this is just some debris on top of there. Let me try to get that flux off. Yep. On this side, we'll work at it just a little bit with a couple things. I like to start by cleaning off these the best I can, just a little bit more. I feel like a little bit goes a long way sometimes. So this is another thing I was talking about Stetson. These are marked C2s. It gives you the C3s, H3s for the outputs. They scrub them and put their own junk on there. Excuse me. That way it's harder to repair. You don't know what chip to use. Let me go ahead and flow this a little bit right here. Oh, let's see. Did it want to mess up? Yes, it did. So let me go back. I have to edit that out. Sorry, my computer the camera glitched out there rather. I'm sorry, my camera glitched out there. So we're back here. I was reflowing this down here a little bit, making the pad a little thicker, a little nicer. Adding some more solder to everything here, trying to make it flow a little better. And this there needs to actually come off. I don't want that coming off any other time. So we'll use some solder braid and flick up a little portion of extra solder that's up there. Alright, I'm happy with that. This amplifier here, I'm now going to put to the side and clean the case up and get that ready. So I'm not trying to mess up any order of any of these components, so we'll actually just go ahead and do it systematically. I'm going to lay this cleaning compound down. Alright. SD card, the camera's having a fun night today. So, go ahead and remove these. Alright. I'm going to go ahead and clean these thermal insulating pads. They're not thermal insulating pads. I want to say non-conductive pads. That'd be incorrect if they insulated thermally. That wouldn't be any good use here. Okay. So I lost a portion of the plastic. That is okay. We're going to wipe this down. Flip this over and get the other side. Clean cloth again. A lot of thermal paste on that side. I'm just going to take one of these other cloths here and clean it off. Something burnt. Maybe not, but there's an extra crusty on that plastic piece. I'll have to take a look and see. I'll have to take a look and see later what it might be. It's okay. All right. Apply the thermal paste here. Yes, I use my finger. If anybody has better suggestion, let me know. It seems like this just works. I don't have to keep buying more of them. Not unless I do something stupid while I'm swapping a motor or something. I might have to buy a couple fingers. This is fun. I like doing this stuff. I really do. One side at a time. Okay. Alright, put this guy back on and move to the next one. Alright. Pull those to the side so I don't have to have those in my way right now. Somebody's out there going, oh, you could use gloves. I could. They're out my garage. I chose not to. Maybe next time. So, is that lined up right? No, there it is. Okay. I just scooped thermal paste on my desk. I'm not too proud of myself for that. Be finished. Alright. Okay. Alright, now that is done, I'll go ahead and clean up the extra thermal paste I probably don't need on these ends here. It's not all over the place. Alright. Now that we are at this step, I need to clean up just a little bit. Just a second, bear with me please. Alright. Now something is lagging, but we're going to keep going. So we're going to take the circuit board and place it back into the heat sink. I'm going to physically check these transistors real quick. Everything looked okay. I'm just visually doing a once over. Yeah, they look okay. Right back in there. Line that up right though. I'll make sure all the transistors are properly isolated. Alright. This looks like it needs to come down and over some, but I won't quite know until. It will definitely come down and over some. Alright, there's a screw hole there. Screw hole there. There. Sounds good. Take these screws and reinstall these. There it is. So I'm going to start all these screws on the circuit board first, that way I don't get to a point where one might be bound or one might be tight. Only a few more to go. I'll have to start with some background music again or something, that way we're not too quiet. If you guys think I should edit stuff like this out, leave in the comments, let me know. It takes me more time to edit it out. I don't have all day long. I come home and usually do these in the evenings. A couple more to go, not terrible. I'm going to pull the transistor clamps back on. I just noticed it doesn't look like it has a lot of filtering capacitance for this output circuit. This is an IRS 2092, no, IRS 2095 72157. IRS 209575 is what it looks like. IRS 20957S. No sense there. I'm just going to go through and tighten all these down. I'm going to start from the middle and work my way out, and then move back on the same side. And then I'll move to the other side and do the same thing. One did not hold on very good. There's one next to it. It should be alright. Alright. Now the transistor clips. There's 3 and 3 on the output. These are fun to do. My hands get a little sore. But it's a big amp, so I'm not using a power drill. Nope, nope. One component hole is not lining up the best. Let's see, there we go. I should have got it there. Yep. Alright. And the final stretch. Get the side panel in here. This is the side with the LEDs. Go ahead and drop this on and that in there. Go ahead and do the same for this side. Plastic's bent here. So we'll fix this. A little better. Now the next side. Like I said, we're going to put some heat shrink around these terminals here. That's to be sufficient for this repair. Couple more screws. Now there are no more screw terminals on the speaker leads. They have worked their way off. I'm going to put some CA glue on this to hold this terminal down and stop it from rattling. I'm happy with that. I'm going to go ahead and put this cover back on. This has a strip that goes along here to stop it from rattling. I'm a little soft-spoken tonight, sorry, I'm a little tired, it's late. Been working a bunch, you know how that goes. Sticker says 12,000 at 12.6, 15,672 watts at 14.4. There we go. There we go. There should be one more tiny screw floating around somewhere. Yes. Alright. Clean the amplifier itself up a little bit now. Spent quite a bit of time on it. It's okay to spend a little bit more and make sure everything is proper. Take a subwoofer and get it up here on the desk. Hook up some terminals here. I am going to screw them down. I don't want this amp having any problems. It's an expensive amp, so I'm going to go ahead and mount the gator clips inside and then tighten the terminal back down a little bit. That way nothing pops out and shorts or anything crazy. Alright, well, the bass boost was halfway up. That doesn't really mean too much though. We'll see if we can power it up on this little test lead or if it's going to be unhappy. Let's see. Okay. No smoke. We're flashing. Not enough power into the input. Maybe it has a problem still. I hope not. Let's go ahead and hook this up a little better. Gotta find a different Allen key. 1 second, please. blue blinking light. Does it need a signal input before it will do something? I think it's not good. I think it definitely has a problem. That's why those transistors look hot, but we'll check it out real quick. Put a phone, slap a phone on there. So it probably has a power supply failure. Now that I'm looking at that there, we'll take a peek. Give me a second here. Let's see if it kickstarts with some kind of music. I don't think it will. Let's see. Blue blinking light. In the manual it says recommended 3 225 amp breakers with triple aught cable. Well, triple aught won't fit in there. Let's see if it says blue. When audio is cut off and it blinks 10 times, it indicates electric tension is under 8.9 or over 16 volts. Is this true? Is my power supply not beefy enough to keep up? I don't think that's the case because we would hear a fan kicking on that power supply. So what is our input voltage here? 13.6 within spec. Well, blinking blue though, it's not happy. Something else is not going inside here, so we'll take the cover back off. I thought for sure it was just going to be a power leak. Should have checked. No shorts, otherwise we would have a power supply draw. Gonna heat this chip up here and cause a problem with the 817N. Good question. Negative, positive. Yeah. You don't want to build real voltage. Yeah, it uses MOSFETs H3 and C2s. I'll have to find somebody who knows where I can get some of those at. Now we're over to our scope. Let me power the scope up. I need to check this little tiny chip here to make sure he is outputting PWM signal into the power supply. Well, we pulse that. How? See the guys. Constant. The reason why this output probably melted off is there's a short somewhere that fed back to that, possibly. A lot of flux on this component. Is that all the problem? That looks fuzzy. Let's see if there was. No, that's okay. Okay. When it's done playing games with me, we'll go to town here. We'll probe this pin here and see if I see any PWM modulation. Oh, nope. No, I don't. Let's check these pins here. See if I can get it for a second. Try. Okay. We're on now. Okay, let me see about getting some gain. Maybe it wanted that pulse multiple times. I don't know truly why. We'll check this out though. The gain is down. I don't want to send everything in oblivion with this amplifier. Just decided to go into protect. Now its power's on. Output. Oh, okay, my speaker cables. My headphone jack is funky. Bear with me 1 second. Let's see if I can get it to kick over. Well, this shit needs new fans now, don't it? Let's listen to that again. To kick on, but I guess it's okay. Yep, it's playing. We're gonna go ahead and shut this down. And that is the repair for now. I'm going to go ahead and let this rail voltage die completely before I try to put the cover back on, so if I drop any screws or anything, I don't have any problems. If you guys have any questions or comments, please feel free to leave them in the description, in the comment section rather. I'll have a link to my contact information in the description if you guys need to contact me for any questions or anything, feel free to do so. Until next time, take care.